So guys, we always talk about how it's bad idea to work with a large set of result set. So if you have like a huge table like this example, we have a student grades and there are like what? 12 million students here, right? Even if you add some sort of filters, let's say, hey, give me all the students that got grades between 90 and 100, right? And if you do that, yeah, you have a smaller result set, but still, it's a million students. Sometimes there is no option but to work with a larger data set. So if you actually execute select the student ID from grades, and you say, hey, give me all the students, you can do that definitely, right? So you can say, give me all the student IDs that got results from 90 to 100. And you can definitely do that. But good luck executing that query. And even if I execute, the database is doing a lot of work to pull, first of all, to do the execution plan, to find out which indexes to use, right? And then after that, it does the actual fetching. And then it compiles the results. And then if you're in another client machine, then that transmits that results into the TCP protocol. Depends on the database protocol. It will shove that into the network. And that is a lot of work. And then the client have to wait for all the results to come back, right? Obviously, I canceled it right here. Once you have all the results in the client, then the client have to have the memory to store all those results. So that is absolutely sometimes impossible to do. Meet database cursors, and I'm gonna talk specifically about server-side cursors here. So cursors that you create on the database. It says, hey, database, please, I'm about to fetch this result, but don't give me the result right now. Create a cursor, and then once you create that cursor, I'm gonna ask you to fetch results from that cursor. And only when I do that, you go and do the work, follow your plan, query or do your index only scan or your bitmap index scan or whatever full table scan if you didn't have any indexes, and then go and fetch those rows for me and then return just the ones I asked for. How do we do that? Let's explain how to do that. It's very, very simple. First of all, cursors have to work within a transaction. So we can do a begin transaction or just begin that does a transaction. And then you can say declare cursor C as type cursor for select star. Or just let's say I'm interested in the ID from grades where the grade is between 90 and 100. And then when you do that, it says, hey, I declare the cursor, it's good to go. You saw that it didn't actually execute the query, technically. It just came up with the map. It came up with the plan to actually plan this query. However, it didn't yet execute it. So now if I do fetch C, that act will fetch the first row based on the query plan that have taken place. So if I do that, give me the first row. Fetch C, give me the second row, and so on. You can go all one by one, and you can play with this as you want, right? And you can, for example, there are many things that you can do. Like, for example, fetch last. Give me the last entry for this for some reason, right? And you can give me, hey, fetch the last entry. And then you can see that the database is doing more work here. Say, okay, to fetch the last entry, I have to kind of scan through all of that stuff to determine what is the last entry, right? To pull that last entry. Sometimes the database have knowledge of how to obtain the last entry in a very efficient manner. Sometimes it actually doesn't, right? And that's when an index backward scan versus an index scan become really, really useful. So guys, what is the advantages and disadvantages? What is the pros of cursors? So the beauty of cursors is you save on memory in the client side, at least in your backend application that connects to the database, right? So if you have a spin up on a Python application or JavaScript or Go application, and you want to process a lot of results, but you want to do them piecemeal. You want to work with them slowly. You can open a cursor and then start pulling a number of rows, like say 100, let's start working with those 100. and then go move to the next one, and then do whatever you want with the 100, right? So you obviously, and then discard the memory for the 100 and then fetch the next ones, right? So it definitely saves a lot of memory, especially in the client side, right? Otherwise, you cannot pull 100 million rows in the memory, right? That's why I always get confused of these questions in interviews. Like, hey, sort this array, and I don't know, it has like a 1 billion row. It's like, what? Where did a billion row came into my memory to sort them? That's a bad idea, essentially, right? So I always like ask the interviewer back. It's like, okay, where are these actual values stored? Are they in a database somewhere? Are they in? Did they came up from thin air? Of course not, right? So if I can sort them while I pulling them up, that's probably a better idea, right? Than pull all of them in memory and then sort them in memory. So be careful from this question. You can essentially flip the interview on the interviewer when you know what you're talking about. So the second pros is streaming, guys. Right? Streaming is a good idea, right? When you want to pull the rows, and as you continue pulling the rows, you can stream them to another WebSocket connection. You can stream to a bunch of gRPC connection, and you can just continue pulling values, right? It can also be canceled, right? You can easily cancel a cursor. And the beauty of this is like, hey, I know I'm about to pull 1 million row, but I only worked with 100,000 and I'm good. Cancel that query, roll back, I'm good now. Go move on. So canceling is a good thing. Paging is another good idea, right? You can page with cursors. However, we'll learn that it's not as easy to page in a web application with cursors, because cursors is stateful. We'll come to that. Also can be used in a store procedure to write PLSQL programming language, fully fledged programming languages with cursors. All right. So about talking about the cons, what's bad about this? The bad about this is it's essentially stateful, right? But when it's stateful, that means there is a memory allocated for it in the database. So and there is a corresponding transaction that points to that cursor. That means if you made another request to another server, to another process, that process has no idea of your cursor. You cannot share cursors essentially, because that's just a property of the transaction. So statefulness is a double-edged sword. Sometimes it's an advantage, sometimes it's a disadvantage if you want to horizontally scale, obviously, right? You cannot horizontally scale. You can do some tricks with proxies. If you know what you're doing, if you're savage DevOps engineer, you can make your web application understand that there is a cursor involved and send some sort of a variable that will stick you back to not only to the same server, but to the same transaction. However, that is extremely difficult to pull out, right? If you really wanted to do that and you can do paging with that approach, that is much better way of the current compared to the current paging that we do, which is essentially a stateless paging. Every request goes into another server, and that server does the query again, which is painful to the database. It's an insult to the database to execute the same query twice. Execute it once and then loop through it with a cursor. That's even better. But sometimes we cannot, obviously, sometimes it doesn't work that way. Another cons is long-running transactions, guys. Cursors, if you want to iterate through a cursor, you have to do it through a transaction. And that means your transaction is going to be running for a long time. And transactions running for a long time is not a good idea for the databases. Databases cannot do indexing properly. If you cannot do DDL on the table if someone is connected, right? You essentially stop people from doing normal work. Some write operations can be stopped by long-running transactions if you have acquired certain shared lock, right? All right, guys, that's it for me today. That was the pros and cons of database cursors demonstrated in Postgres. I'm going to see you in the next one. You guys stay awesome. Goodbye, y'all. In this video, we will discuss the differences between a server-side cursor and a client-side cursor with regard to Postgres database and Python. So here I have a Postgres database in my laptop. I have a table here. I created a database and I created a table. It's empty now. With that said, let's just jump into the video. So what is the difference between a server-side cursor and a client-side cursor? So to connect to the database from Python, you essentially establish something called a cursor, right? You create a cursor, and then you either write or read from the database, okay? And the client-side cursor is when you, for example, execute a select statement. Let's say select all from employees, like here. What happens is all the results are executed and delivered over the network to your client, which is Python, okay? And versus the other approach, where server-side cursors, where uh, a cursor is created on the database, and only when you absolutely need something, the client can say, hey, give me 10 results, give me 30, give me whatever, give me one, give me the next, scroll through the results. And only when you absolutely need it, it will start fetching this result. So the result is actually executed on the server and set there, and the client kind of fetches them incrementally, or if they wanted all of them. Okay, so that's the difference. With that said, let's just jump into it. So to do that, we need actually a large table, and to do a large table, we need to actually populate it with I don't know, like 1,000,000 rows. Okay, so let's go ahead and do that. Okay, and I'm gonna speed up through this process, maybe through the video, but essentially what we're gonna do, let's create a new project. And this is called server versus client cursor, right? It's a new project, so we're gonna go ahead and then let's go ahead and create a file here called insert 1,000,000.py, and that's the file that we will use to essentially create a lot of rows in this table. Okay, all right, so the first thing we need to do is import psycho pg2, and then I want to have obviously establish a connection, right? So that is how you do a connection. What's your host? My machine name is called Hussein Mac. That's where my Postgres instance is. Database equal Hussein DB, and obviously the user is Postgres. The password is Postgres, and the port is 5432, which is the default port, right? So obviously you have to close the connection, make it a habit, okay? And then what we need to do is essentially create a cursor, right? And to create a cursor, you ask the connection, give me a cursor, okay? And then what you do is for I in range, is this 1,000,000? I think that's 1,000,000, right? Go ahead and execute 1,000,000 insert statements. That's the easiest way, right? Obviously, there's like a most optimal ways of doing things, but we're just inserting here. Obviously, I'm gonna skip through this. I'm not gonna wait for all the 1,000,000 stuff to get inserted. Okay, SS, right, ID, and then obviously I1I, and I don't know, the employee's name or test I. Okay, that's a great name. It's a beautiful name. Okay, and then obviously once you're done, you have to do connection.commit. And the reason is you want to commit your changes, right? You don't want to create 1,000,000 rows and then say that. You close it. The whole thing will be rolled back. All right, so let's go ahead and run this, guys. And what happened? I think we're gonna give it an error here. Oh, no, looks good. What's going on? It's going okay. 251. Go ahead, 252. Nice. All right, this is chugging. Let it chug, and whenever it's ready, guys, I will come back. All right, guys, we have 1,000,000 rows, I think. So let's make sure that this is true. Oh, that's wrong. Okay, let's do a count star. Yep, we have 1,000,000 rows. All right, guys. So now that we have 1,000,000 rows, what we're gonna do is insert a new file here, and then I'm gonna call it server cursor server-side cursor.py, and then I'm going to create another file called client cursor.py. So let's start with the client. How do we do a client cursor that actually, what we're going to do is query all the rows and then just measure the time for the query to get executed, and we're going to fetch the first 50 rows. Okay, so that's our criteria, and we're going to do it first with the client cursor, and then we're going to do it with the server cursor. Again, import pcycle, and then connection equal, let's steal. All right, guys, just saving some time here. Okay, I have a connection.close. Okay, let's do a cursor that is client-side cursor. So cursor equal connection.cursor. If you don't specify any parameter here, you get a client-side cursor. Okay, client-side cursor. Okay, and we explained what is that, right? And then what we want to do is cursor.execute select all from employees. Obviously, this is a huge bad mistake to do that, right? But we're doing some performance thing anyway, right? So even with a where clause, sometimes it gets query can get slow, right? But that essentially will execute everything, and then what we will return a bunch of rows for us. Okay, no, that will not return any rows actually. Okay, so cursor.fetch many will actually return the number of rows, and I want just 50 rows. Okay, and I'm not gonna print them or anything. Okay, so now we need to actually measure the time to do that. Okay, and to do that we're gonna import some library called time. All right, I just like use a T so we can do it simply, and then let's do that. Start time, okay, equal t.time. Okay, make a snapshot before we start the cursor, and after we start the cursor we will get the time divided subtracted from the start time. All right, and that will be in seconds essentially, right? So I want it in milliseconds, so I'm gonna just multiply by 1000. Okay, all right, so now we have, and we're gonna print f cursor established in E millisecond. Cool. And then we're going to do the same exact thing for the execute. Cool. And then we're going to do, but this is different now, cursor established, not the cursor established, query all rows. I will just say, let's call this execute the query. All right. And then this is different. This is actually fetching the thing, okay? And this we're gonna explain how is this different, okay? Execute query, and this is actually fetching 50 rows, first 50 rows. Just fetch the first 50 rows and tell me how long it takes, okay? How about we run and see how this is going on, okay? Oh, I forgot to close the cursor, guys. Cursor to close, okay? And then let's start. All right, so let's zoom in here so you guys can read this. Establishing the cursor obviously doesn't take anything. It's just literally declaring that statement, right? So 0.02 millisecond. But look at executing the query, which is we didn't have to actually get the result. It was just executing the query, fetching every single thing into the cursor took 845 milliseconds, and then fetching the first 50 rows is nothing, right? Almost nothing, because we have everything in the client, right? We now, if I look at the processes, like the process is huge. It's containing 1 million tuple row, okay? And obviously, the more you execute, it's a tuple, so it's not an array. So we didn't actually allocate everything, okay? So it's slightly different. It's a read only. All right, so that's the client side. Let's do the server side. Literally copy paste. And the only difference to do a server side, you just give it a name, right? Once you give it a name, it becomes a server side cursor, but it behaves exactly the same, okay? Okay, what did we get? Look at the results, guys. With the server side cursor, executing the query took 3 milliseconds. And now fetching the 50 rows actually slightly slower than the client side, because we still have to make the round trip to give me the 50 rows, but it's a very cheap call, because give me only 50 rows, right? Give me the 50, give me the 50. And if we do a loop, we can see that this is actually we can see that how long it's gonna take, right? Every 50 rows is gonna take 2 milliseconds, right? So there you have it, okay? You have client side, right? If you execute, you pull everything to the client, right? And then the server side, you leave everything on the server, but you will have to do some round trip going back and forth to fetch the results, okay? Or obviously there is no better approach here, okay? I'm not saying server side is best and client sucks, right? There's advantages and disadvantages. Let's start with the client. What's the advantages with the client side server? If I have a client side server, okay, what I will minimize the overhead on the server side, if you think about it, right? Because I'm going to execute everything. The client takes the memory allocation and the execution, right? They're transferring the results, okay, and the client is around responsible of this cursor, right? The server has nothing. Essentially, it serves the connection, and the cursor is closed, right? However, okay, the disadvantage of this is if you execute client-side cursors, what happens is the network bandwidth of the network is huge. If you're pulling a lot of rows, like in this example, obviously it's a bad practice to do so. But if you do that, then you'll end up with a lot of network. You can saturate your network bandwidth, right? Essentially, okay, your bandwidth, and another disadvantage is your client might not have that much memory to process this stuff, okay? So advantages and disadvantages, right? Client, but the server is now relieved of this, right? The good thing about the server side cursor, which is this one, the server side cursors, is what you're gonna do is you execute the server side, and you can see that the client is relieved, right? So you put the overhead on the server versus the client. So the server is now doing more work. The server is keeping hold of these cursors. And imagine hundreds of thousands of clients doing the same thing, opening all these server cursors, and the worst of all, leaking those cursors. Oh my God, right? Your database, you can endanger the database, right? Of just overflowing the database, because hey, so it's like you leaving all these cursors and leaking all of them, okay? But an advantage, if you're using them very moderately and in a smart way, you can actually benefit from server-side cursors, right? So it's like, hey, I'm processing like 1,000,000 rows. Let me process 1,000 rows as a result. Do something with it, like do a map reduce, for example, and do something with an ETL it to something else, right? And then server-side cursors are great for that. If one processing 1,000,000 results or whatever, and then doing something with it, and then fetching 50 rows at a time and doing something with it and exiting, right? But if you shouldn't really use it all the time, especially if the applications, like, you don't just create server-side cursors for the fun of it, right? Because you might leak, and leaking can be dangerous, guys. All right, I think that's the difference between server-side and client-side. Obviously, there are advantages and disadvantages for both, right? Obviously, you can stay with client-side cursors, but you have to be very careful when you're querying. Never do this. Never select all. Obviously, that's a bad thing. Never do an unbounded query like we're doing here. You're gonna do a where clause, okay? Always, you can essentially simulate a server-side cursor by doing, I think, it's called limit, right? give me the first 10 results, right? And if you do a server-side cursor, remember this is a completely stateful operation, right? So you can't really use it well in a web environment. You cannot just do a service that creates a server-side cursor, and like you cannot build it in a stateless manner. Okay, so I really prefer the personally, if you ask me, I prefer client-side cursor, and you have to be very, very diligent to do what you're doing. All right, guys. With that said, that's all for me today. Hope you enjoyed this video. With that said, guys, stay awesome. I'm gonna see you in the next one, guys. Goodbye.